everyone, and welcome to our solution to activity 1. So in our lecture 1, we appreciated the construction of a frequency distribution table, and of course we appreciated the fact that a frequency distribution table is a tool that is used to present data in classes so that those who want to make use of the data may be in position to look at the different attributes of the data. Among the things we talked about, we looked at the elements of a frequency distribution table. And of course, we saw that the frequency distribution table will have a column which captures the class limits. And then we shall have a column which captures the class boundaries. And then we have a column which captures the class mark. And at the same time, we have another element which is the class width. Every frequency distribution table will have a class width. In addition to the class mark as an element of the frequency distribution table, we appreciated that our frequency distribution table will have a column that captures the frequencies, in which the frequencies we said were the number of observations. And of course, the total frequency would be the total number of observations. So activity 1 came in to support that foregoing discussion on the presentation of raw data using the frequency distribution table as a tool for presentation of data. So as you can see in this activity, in the question, we are told that we have 45 marks. These are marks obtained by 45 students, and we are required to make a frequency table starting with a class of 40 to 49. Okay, starting with a class of 40 to 49. So this is my sheet that I've reserved for the solution to our activity 1. And of course, I'll give it a very small title here, frequency distribution table. Now, I'm going to present my solution or my frequency distribution table in some rows and columns. And definitely, I'm going to reserve this column to capture the class limits. So I'll have my class limits right there. Then in this column here, I'm going to capture the tallies. Okay, I'm going to tally that information given to me. And then next in this column, after I've done with the tallying, I will be counting the tallies, the bundles, and then I'll be indicating the frequencies in that column. And then, of course, as we discussed in our lecture 1, we need a column to capture the class mark. A class mark, remember, is one of those elements of a frequency distribution table. And then finally, I'll need a column to capture my class boundaries. So these are the typical columns that will make up my frequency distribution table. So we have been told that starting with a class of 40 to 49, we need to construct a frequency distribution table. Fortunately, the examiner has given us the class. If you just look at our question here, the examiner has given us the class that we should begin with, okay, 40 to 49. But ideally, if you're not told which class to start with, you have to go through a series of steps. So we shall handle the steps that can be taken in determining which best class size and class limit would be good for your set of data. So that is going to be a discussion for another day. I have that in our future discussions. So for today, we have been told to begin with a class of 40 to 49. So it is my belief that the least score here should be between 40 to 49. I shouldn't expect to say 30 here. So let us just cross-check and ensure that we don't have any figure that is below 40 to 49. So when I look at all the scores given to me, I can confidently say that the lowest score in that examination was 46%. All right, so we are sure now that the lowest score is 46 and it fits in the very first class limit that has been given to us. Next, I need to also identify the highest score so that I know the extent to which I'm going to construct my frequency distribution table. So when I look through all these figures, and I know you have looked through the figures, you've tried to read the question. When I read through and I see these different scores, I can confidently say that the highest score obtained is 96%. Okay, I can confidently say that the highest score is 96%. So it means that the class limits must cover the highest and the lowest score. So that is my highest score. As I construct my frequency distribution table, I'll ensure that the last class limits are going to cover 96 and the first class limits are going to cover 46, the lowest score. So going back to our frequency distribution table here, I will bring in the class limits. Of course, I've been told to start with a class of 42, 49. So looking at the size, I see that I'll construct the next class limit running from 50 to 59, okay? And of course, the next one will be 60 to 69. I have 70 to 79, 80 to 89, and 90 to 99. So with 40, 49, I'll be in position to cover the lowest score of 46, and with 90 to 99, I'll be in position to cover the highest score, which is our 96. Now, of course, I've taken on that pattern 40 to 49, 50 to 59, 60 to 69, because of the fact that the class 40 to 49 is of a size of 10, okay? We shall look at those sizes later, but ideally you will see that I have consistently constructed my class limits following an equal class size. Now, the next step is to get the frequencies, of course, using the tallies, okay? The frequencies are going to be obtained after I have done a thorough process of tallying. So, of course, you will all appreciate from your previous studies, you should have appreciated the fact that we go through the tallying process by putting a small stroke across each score and then putting an equivalent stroke in the column labeled tally right here. All right, starting with the score of 74 from our given raw data, we shall put a stroke against the class of 70 to 79. And the reason is that the mark 74 will, of course, fall in this class limit. So I'll put a stroke in the column labeled tally right there. Next, I will move to the next score, which is 63. So I'll put a stroke on the 63, and again I'll put a stroke against the class 60 to 69. And what is the reason? The reason is that the score 63 falls in the class limit 60 to 69. Next, I move to the next score, which is 67. Okay, so I'll put a stroke on the 67. I'll look for the class limit that can accommodate my 67, and of course that is 60 to 69. Next, I'll move to the next score, which is 86. Okay, I'll cancel that one, and then of course I'll put a stroke on the class limit 80 to 89. So that is what we are going to do, and of course we shall continue like that until when we cover all the scores in the raw data. So at the end of the tallying process, if you've done your tallying very well, you'll have a table that looks like this. Okay, you'll have a table with the column with the tallies that looks like this here. So according to my tallying, I've observed that 4 marks fall in the class limit 40 to 49, 3 marks fall in the class limit 50 to 59, and then this is 7 marks fall in the class limit 60 to 69. Then here we have 14 marks falling in the class limit 70 to 79. Then of course here 12 marks fell in the class limit 80 to 89. And then finally 5 marks fell in the class limit 90 to 99. Now those who are doing it for the very first time, you have seen that I have bundles, okay? I have bundles of 5, okay? Now the principle is that every fifth stroke is drawn across the preceding 4 strokes to form small bundles of 5. So exactly that is what I've done. I have been drawing the fifth stroke across the preceding 4 strokes. So the reason for doing this is that it enables one to tell the total number of scorers in each class more easily. Now, at the end of the day, we shall count these different bundles, okay, and strokes, and then we shall include the totals in the frequency column. So, proceeding to what we have got, we have a frequency of 4 in the class 42, 49. We have a frequency of 3 in the class of 50 to 59. We have a frequency of 7 in the class of 60 to 69. We have a frequency of 14 in the class of 70 to 79. We have a frequency of 12 in the class of 80 to 89. So at the end of the day, we shall complete the frequency column with the total frequency, and of course, as we have been told in the question, these are 45 scores. So that completes the frequency column right there. Next, we move into the class mark. Of course, from our previous discussion, we mentioned that the class mark is the midpoint or axis of the class interval. And how do we get it? We get the upper class limit plus the lower class limit divided by 2. Now, when you look at our figures here, when you get 40 plus 49 divided by 2, of course, that is 89 divided by 2. My calculator is giving me a figure that I'm going to bring in my class marks here, a figure of 44.5. Again, for the second class 50 to 59, we shall get our 50 plus 59 divided by 2. And of course, my calculator is giving me a figure of 54.5. Now, for the preceding class marks, you don't need to waste a lot of time. You just get the difference between the first class mark and the preceding class mark. The difference here I can see is a 10. So you keep on adding 10. For example, if I add 10 to 54.5, I'll get 64.5. And if I add 10 to 64.5, I get 74.5. And of course, I add another 10, I'll get 84.5. And if I add another 10, I get 94.5. So those are our class marks, and that completes our column that captures the class marks. Next, we have the column for class boundaries, and I've mentioned that the class boundaries will give a boundary between one class or a group of numbers in a distribution with the next class. So I'm now going to include the class boundaries, and of course in our discussion we mentioned that to get a class boundary you will get the lower class limit, okay, subtract 0.5, okay, and of course if I do that I'm going to get 39.5. So the upper class boundary for this class limit, of course I'll get the upper class limit, I add on 0.5, and definitely that is going to give me 49.5. So I proceed, of course, in general terms to subtract 0.5 from those lower class limits. You have to subtract 0.5. And then what we shall do, we shall add 0.5 to the upper class limits. So we shall end up with class boundaries for the class of 40 to 49. We shall have a class boundary of 39.5 to 49.5. For the class 50 to 59, we shall have 49.5 to 59.5, and so on and so forth. So basically, the frequency distribution table will look like this. However, I need to emphasize on the importance of these class boundaries. I want to further explain the importance of these class boundaries. Now, we mentioned that for the class 40 to 49, okay, for the class 40 to 49, the class boundary we have got is 39.5 to 49.5. So the class 40 to 49 should include only those marks which are greater than 39.5 and less than 49.5. So anything that is greater than 49.5 should go to the next what? Should go to the next class. Anything that is less than 49.5 should go to the previous what? To the previous class. So that is the interpretation. I can repeat for using this class limit 80 to 89. So the marks that should come to this class limit 80 to 89 should be those that are greater than 79.5 but less than 89 point what? 89.5. So in most cases, these class boundaries are used to help in demarcating the boundary between one class and the next what? And the next class. So all in all, this is how we construct our frequency distribution table. I have shown how to get the tallies. I've mentioned that you're going to make a stroke, okay? You're going to put a small stroke across each score and then put an equivalent stroke in the column that has been labeled tally as the counting progresses through the raw data. At the end of the day, after you have put all the tallies, you saw the tallies we had here in the previous slide. Of course, after putting all the tallies, you saw all the tallies that we had in the previous slide. You will count the number of strokes and then put the totals in the frequency column. So we, of course, put all the totals in our frequency column here, and we are able to get the total frequency as 45. If you find that you have less than this, then it means that you have maybe skipped a score, or if you have more than 45, then to mean that you have maybe double counted your score. So you have to be very, very careful. This can be your checkpoint to see whether you have done a good tallying, and of course you have arrived at the right frequencies. For the case of the class marks, we shall see the importance of the class marks as we move into the other tools like the histogram and the frequency polygon. The class mark is the midpoint of the class interval obtained by getting the upper class limit plus the lower class limit divided by 2. Or if you don't use that route, then you can get the class marks through the class boundaries, still by adding the upper class boundary to the lower class boundary, and you divide by 2. We have also mentioned that the gap between two consecutive class marks, for example 44.5 and 54.5, is equivalent to the class what? Is equivalent to the class size. So by getting the first two class marks, you simply get the difference and continue to add the difference to the subsequent class marks. There you'll be in position to complete your column for class marks. And then again, we mentioned in our lecture 1 that class limits are the smallest and the largest observations in each class. And of course, we mentioned that each class has two limits, the lower class limit and the upper class limit. The lower class limit of a class is the smallest data observed, okay? And then the upper class limit is the largest data value that can be got into that what? Into that class. So we have fully answered our activity 1, which is the construction of a frequency distribution table. So we are going to make use of this frequency distribution table to discuss a number of things, including how to determine measures of location, how to determine measures of dispersion, and how to determine measures of skewness.